Everyone, in this video we are going to discuss this example which is based on intermediate value theorem. Okay, we will try to understand the meaning first and then we will discuss its solution. I am drawing the diagram here, y-axis, x-axis. They have clearly mentioned f and g are two functions which are defined on closed interval AB. Suppose point A is here, B is here. We have two functions defined on this closed interval AB, and the most important thing that both are continuous. They have given this additional information f of A less than g of A. That means suppose at this point A, suppose f of A is here, and at the same point g of A, suppose here. So you can easily see that g of A is greater than f of A. Okay, g of A is greater than f of A. But at point B, we are getting exactly opposite inequality. That means in this case, at point B, f of B is greater than g of B. Suppose g of B is here. So g is starting at this point and going up to this B, and function is continuous. So the function will be like this. Get it? And f is starting here, f of A, and going to this B, so the function will be like this. Both are continuous functions, right? In this diagram, you can easily see both curves will definitely intersect at least at one point, okay? We have to prove that there exists some point C between A and B. There exists some point C belongs to this open interval AB such that f of C is equal to g of C, okay? So at this point of intersection, we will get both values are same. So that means f of C is equal to g of C. At this, there is some point C in this open interval AB. For that point, those curves will intersect. That means they will give the same value. It means f of C is equal to g of C. So with the help of this diagram, we have understood the meaning. So now we have to prove this thing with the help of intermediate value theorem. Okay. So let us go further. So what will I do? I am going to define one function, okay, to prove this thing. I am defining a function h from closed interval AB to R, okay. On the same closed interval AB, I am defining a function as, and its definition is h of x is equal to f of x minus g of x. I use the same given functions f and g to define my h, right? Okay, that's it. So the important thing is f and g are continuous on closed interval AB. If you subtract two continuous function, obviously the resultant function also continuous. Let me mention here f and g are continuous on closed interval AB, then f minus g is also continuous on the same closed interval AB. So we have already seen if you have two functions, continuous function, their addition is continuous, subtraction is continuous, multiplication is continuous, and division is also continuous, providing denominator is not equal to 0, right? So by using that result, I got f minus g is also continuous, but f minus g is nothing but our h, so I can declare h is continuous on closed interval AB. So this is very basic and very important condition to apply intermediate value theorem, that function must be continuous, and yes, our function h is continuous right now, okay. So let us find the value of h at point A and B. Let us see what will happen. So now I am going to find h of A. H of A, that means simply I will put A here. If I put A here, f of A minus g of A. But see, they have mentioned f of A is less than g of A. This is mentioned. Getting? That means I am subtracting a larger number from smaller one. Getting? So obviously, if you subtract large number from a small number, you will get a negative value. So it is less than 0. Okay. So let me write here. Therefore, h of A is less than 0. Now I will find h of B. In this definition, I should put x is equal to b. So you will get f of b minus g of b. So in case of B, this type of inequality we have, f of B is greater than g of B. That means f of B is greater than g of B. That means we are subtracting a smaller number from a larger number. So you will get definitely a positive value. It means it is greater than 0. So therefore h of B is positive. Okay. So what we have got, we have a continuous function on closed interval AB. At point A, value of function is negative. At point B, the value of function is positive. Then definitely we can apply intermediate value theorem, and it says there exists some point C where the function has exactly 0 value. Therefore, by intermediate value theorem, there exists some point C belongs to open interval AB such that h of C is equal to 0. Okay, so there is no more space to write, just make a screenshot of it, then I will go further. So let me tell you again what is intermediate value theorem, since different statements are there, okay, in different books. So the definition which I am following, that is, if function has negative value at point A, if function has positive value at point B, and the function is continuous on closed interval AB, then definitely there is some point C where the function has value 0. So this is our statement of intermediate value theorem, and this theorem says, and the same conditions we have got for H, no? H is continuous. At A, H has negative value. At B, H has positive value. So therefore, there exists some point C in open interval AB such that h of C is equal to 0. Okay. So therefore, what is h of x? F of x minus g of x. So by definition of h of C is nothing but f of C minus g of C is equal to 0. Let us shift g of C on that side. So you will get f of C is equal to g of C. Okay, so the thing which we want, we got now. F of C is equal to g of C. In this way we proved if f and g are satisfying these conditions, then definitely we can find some point C in open interval AB. For that, at that point, the function, both functions will have the same value. Okay, so the solution is over. Make a screenshot of it, then we will stop. Thank you. See you in next video.